This video is the fourth on the SAT Math substitution strategy. And so far we've looked at multiple choice questions, where you choose numbers that meet the condition of the problem, then solve it as an arithmetic problem, and the third step is to check the answer choices by substituting the numbers in to get them a match with your solution. But the strategy can also be used with grid-in problems, except you don't do the third step, because grid-ins are looking for a numerical answer. But you can still, for those type problems, choose numbers and use them to get answer to grid-in questions when it's a question that deals with relative quantities. This will become clear with some specific examples. If you want to try this on your own before looking at the solution, you can pause the screen now. Here, if the length of a rectangle is increased 50% and the width is decreased 50%, what is the effect on the area? There are no variables in the question or the answer choices, but you can still work with specific amounts because it's dealing with relative quantities. So let's get some specific rectangles here. Let's make the initial rectangle, say, 60 by 80. And let's see, so its length is increased by 50%. So 50% of 60 is 30, so that on it gets 90. And the width is decreased by 50%, so that's 40. Okay. So what is the effect on the area? So the initial area is 4,800, and the new area is 3,600. And this is 3/4 as large, so that's the answer. So the reason you can work with specific numbers, the area of a rectangle is length times width. So whatever the length and width was, that would be the area of the original. And as they change, if the length is 50% more, that's 1.5 times its original length, and the width is 1/2 of the original width. So 0.5 times 1.5 is 0.75. So no matter what the original length and width were, the new rectangle would be 3/4 of its area. This is an example that you would find in the grid-in section. If you want to try it on your own before looking at the solution, you can pause the screen now. If you get a 20% discount on an item already reduced 50% from its original cost, what was the total discount? There are no variables in the question, and there aren't any answer choices, but you can still choose numbers since it's dealing with relative amounts. For percent problems, I like to draw blocks. Okay, so, and since we're dealing with relative amounts as percents, why not choose 100? As we'll see, it makes calculations a little easier. So if it's reduced 50%, okay, so the new amount would be $50 after the first discount. Okay, and note that you should be wary that 70% seems like too easy of an answer. Okay, so, and now you're getting a 20% discount, not on the original 100, but 20% on 50. So So your discount here is 20%, which is a $10 discount. So your final price is $40. And in terms of the original amount now, that $40 is a 60% reduction, because the parts have to add up to 100%. And that's the reason why it's a good idea to just start with something like 100. It makes your percent calculation easier. Next problem. If you want to try this on your own before looking at the solution, you can pause the screen now. If you place X grains of rice on the first square of a chessboard, and on each successive square place double the amount as on the previous square, how many times more grains are on the 8th square than on the 3rd square? So there are no answer choices here. It's a grid-in problem, so you need a specific number. But since you're dealing with relative amounts, you can work with some specific numbers. Okay, so here I've chosen 7 for the first square. So as we double, 14 for the second, 28 for the third, and so on. And it wants to know how many times more on the 8th than on the 3rd square. So it's saying the 8th, which is 896, is how many times more than on the 3rd square, which is 28. So to solve for k, you divide both sides by 28, and you get an answer of 32, which is what you would grid in. And the reason you can work with specific numbers is that with relative amounts, well, whatever x is here, this would be 2x, and then this would be twice that, or 4x, or you could think of it as 2x squared, so this would be, excuse me, 2 squared times x. This would be 2 cubed times x, 2 to the 4th, 2 to the 5th, 2 to the 6th, so this would be 2 to the 7th times x. And I mean, you could use these with specific numbers. Whatever it was, you would have that number times x is equal to how many times larger than here, which is, well, if we do it with the power, it would be 2 squared x. So the x's are going to cancel out, so you would be dividing 2 to the 7th by 2 squared, or whatever this number is, by 4, and that would be 2 to the 5th, which is 32. Next question. If you want to try this on your own before looking at the solution, you can pause the screen now. Circle A's radius is 8 times circle B's radius. If circle A's radius is cut in half and circle B's radius is tripled, what is the new ratio of A's area to B's? So again, a grid-in question with no answer choices, but since it's talking about a ratio, i.e. relative amounts, you can work with specific numbers. So let's start with some numbers for the initial radiuses. Okay, so let's make a circle. Okay, so let's call this circle A, and this circle B. So let's make B's radius 3. So 8 times this would be 24. And call this the new radius A prime, and or the new circles A prime and B prime. Okay, A's radius is cut in half, so that's 12. And B's is triple, so that is 9. What is the new ratio of their areas? Well, area is pi r squared. So the and it should have been the ratio of A's area to B's area. So this is pi times 12 squared over pi times 9 squared. So the pi's are going to cancel out, and you get 144 to 81, which is 1.7 repeating. And if you gridded it into 4 squares, 1.77 would be an acceptable answer. If you truncated it, if you rounded it to 4 places, 1.78 would also be correct. Okay, and why does it work? Well, let's say whatever you chose for B's radius, r, then this would be 8r. And if A's radius is cut in half, this would be 4r. And if this is tripled, this would be 3r. So the ratio of their areas would be pi times 4r squared relative to pi times 3r squared. So the pi's will cancel out, and you'd have 16r squared over 9r squared. So no matter what the radius was, the radiuses would cancel out, and it would be 16 over 9, which would be equal to that. To summarize, when you're dealing with relative amounts, whether in multiple choice questions or especially in gridding questions, you can work with specific amounts. This is the end of the 4th session on the substitution strategy. Hope you've enjoyed it.